So this video is on the objective determine the critical value or critical values, if it's a one-tailed or two-tailed test, for a hypothesis test for the difference of two means, two population means. But this is where the population standard deviations are unknown. Right, so a student's t-distribution will be involved. And in order to define rejection regions, right? Remember, these critical values are the borders, the boundaries of your rejection regions. And then you find, a test statistic and determine whether or not the test statistic is in the rejection region. And then go from there and make your conclusions. All right. So, again, if you want to see more of what they have to say about this stuff, you're unfamiliar with the topic, click on more instruction and look at their videos, their notes, their examples, and hopefully those help you. All right. So here, a farm. Right, a farm has a large cornfield with two artificial ponds along the east and west borders. Brennan Castillo is an environmental science student who is investigating whether the population mean concentrations of a particular pesticide are different in the two ponds. So Brennan collects water samples from random locations and depths in each pond. The mean concentration in the 35 samples Brennan collected from the pond to the east of the field is 6.22 parts per billion, with a standard deviation of 2.41 parts per billion. The 35 samples Brennan collected from the pond to the west of the field have a mean concentration of 5.84 parts per billion and a standard deviation of 2.53 parts per billion. All right, so we're told here to let mu1 be the population mean concentration of the pesticide in the pond to the east of the field, and mu2 be the population mean concentration of the pesticide in the pond to the west of the field. Now first, they're not even asking us for critical values here. They're just asking what type of test this is. I think there might be another part to this question where they get into critical values. But right now they're asking us to set up the hypotheses and state what kind of a test is it. Is it a right-tailed test, a left-tailed test, or a two-tailed test? All right, so I'll go to a piece of paper. Now, remember, every hypothesis test, when we do it fully and do all the steps, begins with a claim or a belief or something that's trying to be determined. Now, if you read through this here, I'll read it out loud here. Let's see. Yes, so the second sentence was this. It's, Brennan Castillo is an environmental science student who is investigating whether the population mean concentrations of a particular pesticide are different in the two ponds. So what he's testing, what his belief is, or what he's investigating is that, mu1, the mean concentration of the pesticide in the east pond, is different, not equal, to the mean concentration of the pesticide in the west pond. Now, an alternative way of saying this is just to subtract mu2 from both sides. Another way to say this is that mu1 minus mu2 must not be equal to 0 then. Alright, so a claim is formed, something that's being investigated, something that's believed, something that's claimed, whatever. And then once a claim is established, then you can set up your hypotheses, right? You have a null hypothesis, an alternative hypothesis. And, this claim here does not involve equals. It's not equal, so that's going to be represented by the alternative. So mu1 minus mu2 is not 0. Whereas, and then the null hypothesis and alternative hypothesis should be opposing statements, right? And the opposite of is not equal to is equal to. So the null hypothesis, again, would be what you'd assume, and then decide whether or not you're going to reject it later. So you're going to assume that the mean concentrations are equal, right? That their difference is equal to 0, that they're the same. And then this alternate or the alternative hypothesis, how that looks, tells you what kind of a test you're running, right? How many tails. And if it's the parameter is not equal to some value, remember that's a two-tailed test. So when we go to find critical values and rejection regions, there's going to be two of them, right? One on the right, one on the left. If it was just a greater than, it would be a right-tailed test, and there'd only be one critical value, one rejection region. Right? If it was less than 0, it would be a left-tailed test. Same thing, only one critical value, one rejection region here. But this is a two-tailed test. All right, and that's all they're asking us to do at the beginning here. So it's a two-tailed test, right? Because the alternative hypothesis would be that mu1 minus mu2 is not 0. Right. As I said, different in the two ponds. Now, if it said greater in one pond or less than one pond, that would change things. All right, now there's more to it. So Brennan tests this alternative hypothesis with alpha equal to 0.05 and 68 degrees of freedom, which is 35 plus 35 minus 2. Right? The sum of the sample size is minus 2. Remember, that was the number of degrees of freedom in the pooled situation when we assume the population variances are equal. And I guess he's doing that here because these are two similar ponds. They're relatively close to one another, so I guess he's assuming that the variance for the ponds will be equal, so that's why we're doing a pooled test here. So Brennan's testing this alternative hypothesis with a significance level of 5% and 68 degrees of freedom. So what is or what are, in this case it's a two-tailed test, so there'll be multiple critical values for this hypothesis test. And use the values from the table. All right, now, like I said, we're working, I'll go to a piece of paper again here, and we have our hypotheses developed. The significance level he's using is 5%. Remember, this significance level is the area of the rejection regions put together, if there's two of them. And the distribution of our difference in sample means, x1 bar minus x2 bar is, it looks like he's doing a pooled scenario here. So it's a t-distribution with 68 degrees of freedom. I'll draw that. Horizontal axis here, number line, where these are t-scores. It's a symmetrical bell-shaped curve. Underneath the peak is a t-score of 0. And again, it's a two-tailed test. Right? So there should be a rejection region on the right of the mean, on the right tail, and on basically the same rejection region, but on the other side, on the left tail. Now the area of both of these put together should be the significance level, 5%. So each of these separately should have an area of 2.5%, right? 0.025. Same thing for this left tail rejection region, should have an area of 0.025. So what I'm looking for in this t-distribution with 68 degrees of freedom are what's the t-score with 2.5% above it, and then what's the opposite of that, right? Negative t 0.025. And those can be found with a calculator and the inverse t function. but they gave us a nice table here. So you see I'm going here, degrees of freedom, 68. So I'm in this row here, right, with 68 degrees of freedom. And then I'm looking for the t-score that has, 2.5% above it. This is 10% above it, 5% above it. I want the one with 2.5% above it, and that's 1.995. All right, so back in my picture, these critical values, this t-score is 1.995, and then this one over here would be negative 1.995. And then if we calculated a test statistic, which hasn't been done here, but we could, if we calculated a test statistic, we'd figure out where does it fall, beyond 1.995 or beyond negative 1.995, or does it fall in between them? Is it in a rejection region or not? But that's all we're asked to do here. Just determine these two critical values for the test. And it says use the values from the table. Use a comma and a space to separate answers as needed. Well, anyway, the lower critical value, the lower one would be negative 1.995. The upper critical value would be positive 1.995. So determining critical values, remember, depends on, for t distributions, depends on the number of degrees of freedom and the value of alpha, right? What are the areas of the rejection regions? What do those need to be? And they showed you exactly what I did earlier. Okay, and I believe that's the end of it. Let's see, hit continue. Yeah, that is the end of that question. All right. So hopefully, watching me do this, work with this, and looking at more instruction, looking at the answer explanations when you can. Hopefully, all this stuff helps you when you're doing this on your own. And thanks for watching.